Boom! Just like that, the universe went from nothing to everything. And no, that wasn't your microwave exploding, though it kind of felt like it, right? Today we're diving into the OG fireworks show of the cosmos, the Big Bang. But don't worry, you won't need a PhD in astrophysics or a time machine, just a comfy chair and your curiosity. Ready? Let's rewind the clock, all the way back to the birth of, well, everything. Yep, that's it. All the galaxies, stars, planets, and yes, even that weird sandwich in the back of your fridge, packed into this teeny, tiny speck. Confused? Perfect. Stick around, and I promise we'll make sense of it all. Big Bang style. First things first, what exactly is the Big Bang Theory? Well, it's not a TV show about nerdy scientists, though that's pretty cool too. The Big Bang Theory is our best explanation for how the universe came to be. Imagine rewinding the entire universe like a giant cosmic movie. As we go back in time, we see galaxies getting closer together, stars unforming, and everything becoming hotter and denser. Keep rewinding, and eventually you reach a point where everything in the universe is squeezed into an incredibly tiny, hot, dense point. This is what we call the singularity. About 13.8 billion years ago, this singularity suddenly began to expand. And when we say suddenly, we mean it. In less than a second, the universe exploded into existence, expanding faster than the speed of light. This rapid expansion is what we call the Big Bang. Now, you might be wondering, wait a minute, didn't you just say nothing can travel faster than light? Good catch. While it's true that nothing can move through space faster than light, space itself can expand faster than light. Mind-bending, right? Let's break down what happened in those first few moments after the Big Bang. In the first fraction of a second, the universe underwent a period of incredible expansion called cosmic inflation. This expansion smoothed out the universe and made it look largely the same in all directions. As the universe expanded and cooled, it became possible for the first particles to form. We're talking about quarks, electrons, and other subatomic particles. About 3 minutes after the Big Bang, these particles started coming together to form the first atomic nuclei, mostly hydrogen and helium. Fast forward about 380,000 years, and the universe had cooled enough for atoms to form. This is when the universe became transparent, allowing light to travel freely for the first time. Now you might be asking, if this happened billions of years ago, how do we know about it? Great question. We have several pieces of evidence that support the Big Bang Theory. First, there's the expansion of the universe. In the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us, and the farther away they are, the faster they're moving. This suggests that the universe is expanding, just as the Big Bang Theory predicts. Then we have the cosmic microwave background, which is like an echo of the Big Bang. It's a faint glow of radiation that fills the entire universe, left over from when the universe became transparent. It's exactly what we'd expect to see if the Big Bang Theory were true. Lastly, there's the abundance of light elements. The Big Bang Theory predicts specific amounts of hydrogen and helium in the universe, and that's exactly what we observe. Now let's address some common questions about the Big Bang. Question: what caused the Big Bang? Answer: honestly, we don't know. Our current physics breaks down when we try to describe what happened before the Big Bang or what caused it. It's one of the biggest mysteries in science. Question: what was there before the Big Bang? Answer: again, we're not sure. Some theories suggest there was nothing, while others propose the possibility of a previous universe or multiple universes. But these ideas are still in the realm of speculation. Question: does the Big Bang disprove the existence of a God or creator? Answer: not at all. The Big Bang Theory explains how the universe evolved, but it doesn't address why it came into existence. Many people find ways to reconcile their religious beliefs with the scientific evidence for the Big Bang. It's important to remember that while the Big Bang Theory is our best explanation for the origin of the universe, it's not set in stone. As we make new discoveries and develop better tools for observing the cosmos, our understanding might change or become more refined. The study of our universe's origins isn't just about satisfying our curiosity. It helps us understand fundamental physics, the formation of galaxies and stars, and even the conditions that allowed life to emerge on Earth. Plus, it reminds us of our place in this vast, awe-inspiring cosmos. The next time you look up at the night sky, remember, you're gazing at the aftermath of an explosive beginning that happened billions of years ago. Every star, every planet, and even you are made of stuff that was once part of that initial singularity. We are, in a very real sense, children of the Big Bang. So, what did we learn? The universe is old, big, and still growing. And much like your hunger after watching this video, it's never quite finished. But hey, at least the universe gave us stars, planets, and Wi-Fi. So, the next time you look up at the night sky, remember, you're literally stardust. Yep, you. Now go share that with someone and watch their mind explode. Alright, space explorers, that's a wrap. Until next time, keep looking up. And don't worry, you won't fall into a black hole. Probably.